In our final chapter on N-hair, we will look at rendering. If the hair is animated, then you will need to build a nucleus N-cache before rendering. The N-cache is simply the simulation stored on disk. There are several reasons why you need to do this. First of all, if the simulation is stored, then Maya doesn't have to calculate it again and again. So your viewport performance will be much better, and you'll be able to do other things at the same time, like character animation, if it's a lightweight cache. Another important reason why you need to cache your simulation is because if you don't, when you do a batch render, you may get unexpected results. The hair may do things that it didn't do when you were looking at it in the interactive viewport. And third, if you don't cache your simulation, then each successive frame of your batch render will take longer and longer to render because Maya's dynamics are so-called history dependent. They depend upon what happened on the frame before. So if you're on frame 100 of a batch render, then Maya has to calculate the simulation for all frames leading up to that, frames 1 through 99. Then when the batch renderer goes on to frame 101, it has to recalculate all of that same data again. So it's a huge waste of time and resources. So you have to cache your simulations, otherwise your render times will be incredibly long. Okay, well first we need some animation here. What I'm going to do is just add some wind to the hair, and that's pretty easy to do. And along the way, we will look at a couple dynamic properties and also create some simple expressions for the wind. I'll select the hair and go to the attribute editor and go to the hair system shape node. And previously we had set a bunch of attributes to make sure that the hair stayed put. And now we need to make sure that we turn all those attributes the other way so that the hair will move. So in the collision section, we need to turn off the stickiness, turn that off down to 0. In the dynamic properties section, we need to scroll down and find start curve attract and turn that off as well. Under forces, in order to get a good wind effect, we need more drag. Remember that drag is the air resistance for the hair. So we want to turn that up. In fact, I'll turn that up all the way to its maximum of 1. And so that the hair will flow freely, I'll turn the damping off completely. So those are the collision and dynamic attributes of the hair system shape that we need to change in order to make the hair flow freely in the wind. Now we'll add wind, and that's done through the nucleus node. So I'll click on the nucleus node. And in the gravity and wind section, we've got the wind speed, direction, and noise. Wind direction is in X, Y, and Z. The default value is a 1 for X, which means it's going to blow in positive X. So over here you can see we've got our axis tripod. That means the wind is going to blow in this direction, from screen left to screen right. What I want to do is I want the wind to predominantly blow towards the character's face, and that means it needs to be in the negative Z axis. So I'll set wind direction Z to -1. I also want the wind to blow downward as if it was coming from the sky. So the wind direction Y here should be set to, let's give it -0.5. Wind direction X I want to vary over time. I want the wind to blow in different directions so that the hair will not just stay static and it will continue to move around. I will add a simple expression to wind direction X. I'll right-click on that field and choose Create New Expression. That opens up the expression editor. And you'll see it says Nucleus 1 Wind Direction X is the selected object and attribute. I can select this and then just middle mouse drag it down into the expression area. And what we want to do here is set it equal to a noise function that's driven by time. I can make this text a little bit larger so we can read it better by holding down Control and turning the wheel on the mouse. So I'm going to set this equal to a noise function that's driven by time. I'll set it equal to noise and then open parenthesis time, close parenthesis, and then a semicolon to end the line. But if I left it at that, what we would get is a noise that was not really fast enough and that varied from a value of -1 to +1. The noise function outputs a range of values from -1 to +1. So what I'll do here is I will change this up just a little bit. I'll say the input to noise is time, but we'll make it time multiplied by 2, and that'll speed time up. Now time is going to run twice as fast inside that noise function. And then in order to constrain the values so that it's not the full range from -1 to +1, I'll divide this whole term by 2. So I'll put an open parenthesis at the beginning, another closed parenthesis at the end, a division sign, and then a 2. So what we will get here is time running twice as fast, and then the output of the noise function is going to be divided by 2. And click Create and close. And if we turn the wind speed up to, let's say, a value of 300, and then press play in our timeline, we should start to see some movement here. Okay, so we've got a constant wind speed of 300, and the wind direction is the only thing that's changing. I want to make this a little bit more interesting. I'll stop it, rewind it, and put an expression in the wind speed as well. So I want to enter an expression into the wind speed field here. I'll right-click and choose Create New Expression. And then the selected object and attribute is nucleus1.windspeed. I'll select that string and middle mouse drag it into the expression area. Hold down Control and turn the mouse wheel to make that text larger. Okay, so we're going to set this equal to a noise function that's driven by time as well. So if I put in noise and then as the input to noise time times 2, then we will get the same pattern of noise that we see in the wind direction expression, because there's only one noise function in Maya currently. What we want to do is have it so that they're not synchronized. And the trick to that is to add some arbitrary value. So what I'll do here is I'll put another parenthesis here, and then a plus sign after the time times 2, put in a plus sign, and then some arbitrary value. Let's give it, let's say, 978, and then close that parenthesis. And now what we will get is time is going to be sped up by a factor of 2, and then that time will then be shifted over by 978 frames. And then that will be the input to the noise function. Well, we're almost finished here. What we need here is we need to have a much greater value to the noise. Currently, we'll just get the output from -1 to +1. So we need to crank this up. So I'm going to take all of this and multiply it by 300. So I could do this. I could put in a multiplication symbol and multiply it by 300. And that's then going to make that a range not from -1 to +1, but from -300 to +300. But that's not a good range because -300 will cause the noise to push in the opposite direction. So I'm going to offset this now by another 300, meaning that if we get a -300 value, we're going to add 300 to it, so it'll equate to 0. So I'm going to put all of this once more into a parenthesis, brackets, and then add a value of 300 to it, and then close with a semicolon. Okay, so that's a little bit of algebra there for you, but this is a very useful technique, and this will allow us to now get the range of values that we need. What I'm going to get here is a range from 0 to 600. And the noise function will very rarely ever reach those extremes. So in reality, we'll probably get an overall range of somewhere between 100 to 500. Okay, so that's our noise expression for the wind speed. I'll go ahead and click Create. I don't get any errors down here. And then I'll close that window. And notice the wind speed now is 582 on frame 1. And if I step through one frame at a time, we can kind of get a sense of what the wind speed and direction values are going to be. And you can see that it's varying on each frame. All right, cool. And let's set our time range to 120 and play it and see what we get. So I think we're getting a pretty good result here, and we can go ahead and cache it. I've got a scene that I've already made that's called 501 Creating Encache Finished. And I'm going to open that. I'm going to cache that scene. I'm not going to cache this one that's called Creating Encache, because if I did that, then when you try to create the cache, you will get an error message saying that it already exists if you're using the exercise files that come with the course. So I'm going to load my finished scene, but you don't do that. You don't want to, and you shouldn't, but I have to. Okay, so I'm going to open that up. And now I'm ready to create the cache. I'll select the hair and go into the Encache menu and choose Create New Cache Options. And it just fills in all the information for me, really. It's going to create a subfolder inside the cache folder in my current project. And it's going to be called the name of the current scene file. And then the files within that folder will be named the selected hair system shape object. Go ahead and click Create, and Maya will play through the simulation once, storing frames as it goes. The Encache is finished calculating, and we can close our attribute editor and rewind and play it back. And you can see that it's moving much faster. And that's because Maya is not calculating the simulation anymore. It's simply reading it off of disk as fast as the disk is able to feed the information. And I can actually scrub through, jump through in my timeline, which is something that I could not do previously when there was no cache. And that's all there is to creating the Encache. We can save our scene now, and when we're ready, we can go ahead and batch render it, and we won't have any issues.